Alright, so in this problem, I have 4 to the power of x is equal to 8. So obviously here, I want to find the value of x. So for my solution, first start by rewriting my problem. So I have 4 to the power of x is equal to 8. Now 4 here, this is the same thing as 2 squared. So I'm going to rewrite this as 2 squared to the power of x. All I did was replace 4 with 2 squared. And now 8, this is the same thing as 2 to the power of 3. So I'm going to replace 8 with 2 to the power of 3. So I have 2 squared to the power of x is equal to 2 to the power of 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2 to the power of 2x. And now this is equal to 2 to the power of 3. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. Meaning, in this case, 2x is equal to m and 3 is n. So I have 2x is equal to 3. And this is a simple equation. All I have to do is divide both sides by 2. So then these two cancel out, and I get x is equal to 3 over 2. Alright, so in this problem, I have x to the power of x plus 1 is equal to x. So to solve this, I'm going to start by subtracting x on both sides. So then these two cancel out, and I'm left with x to the power of x plus 1 minus x is equal to 0. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x plus 1, this is going to be equal to x to the power of x times x to the power of 1. Now I have this minus x is equal to 0. Now if I factor out x, I get x times x to the power of x minus 1 is equal to 0. So now this gives me two equations. I have x is equal to 0, and I have x to the power of x minus 1 is equal to 0. So x equals 0. This is already a solution. Now for x to the power of x minus 1 equals 0, I'm going to add 1 on both sides. So then these two cancel out, and I get x to the power of x is equal to 1. Now, because x has to be the same number, we obviously know that, well, what number to the power of itself is equal to 1? That's going to be 1, right? Because 1 to the power of 1 is equal to itself. So x is equal to 1. And there's no other number that when you take the power of itself is going to equal 1. Meaning x equals 1 is the only solution to this equation. So now to check, the original equation was x to the power of x plus 1 is equal to x. So x to the power of x plus 1 is equal to x. And our first solution is 0. So if I plug in 0, I get 0 to the power of 0 plus 1 is equal to 0. Now 0 plus 1 is 1, so I have 0 to the power of 1 equals 0, and 0 to the power of any number is itself, so I get 0 equals 0. Now to check for 1, I get 1 to the power of 1 plus 1 is equal to 1. 1 plus 1 is 2, so I get 1 to the power of 2 is equal to 1, and 1 to the power of any number itself, so 1 equals 1. Alright, so in this problem, I have x to the power of x is equal to 100. So I'm going to first start by taking the natural log, or ln, on both sides. So I have ln x to the power of x is equal to ln 100. Now, if I have something in the form ln a to the power of b, I can move this x1 and b to the front. So this is going to equal b times ln a. So for ln x to the power of x, I can move x to the front, and I'm going to get x times ln x is equal to ln 100. Now ln 100, that's the same thing as ln of 10 squared. So I get x times ln x is equal to ln 10 squared. And if I have something in the form ln a to the power of b, again, I can move 2 to the front, so I get x times ln x is equal to 2 times ln 10. Now, there's something called the W Lambert function. And if I take the W Lambert function of something in the form a times e to the power of a, this is going to equal a. So this is basically what the W Lambert function is. So if there's something in the form a times e to the power of a, that's going to equal a. So what I'm going to do over here is I'm going to rewrite x here as e to the power of ln of x, because the e and ln cancel out, and this results in simply x. So I'm just going to rewrite x as e to the power of ln x, and I have this times ln x is equal to 2 times ln 10. And now this is in the form a times e to the power of a. So now if I take the W Lambert function on both sides, this results in ln x equaling w of 2 times ln 10. And now if I take e to the power of both sides, I get e to the power of ln x is equal to e to the power of w of 2 ln 10. And e to the power of ln x, that's going to equal x. So I get x is equal to e to the power of w of 2 times ln 10. And this is equal to 3.597285, which rounds up to 3.597. So this is my answer to this problem. Alright, so in this system of equations, I have x squared minus y squared is equal to 28, and x times y equals 48. So I'm given two equations. Let's just say that this is equation 1 and this is equation 2. So what I want to do is find the value of x plus y. So what is the value of x plus y? And finding this is fairly simple when we find the value of x and the value of y. So to start, what I'm actually going to do is I'm going to use my second equation here. So equation 2 is x times y equals 48. And what I'm going to do is I'm going to solve for one variable in relation to the other. So it doesn't matter which one, but for this case, I'm going to solve for y. And to solve for y, I have to isolate it, meaning I have to get rid of this x by dividing both sides by x. So I get y is equal to 48 over x. Now, using this equation, I can plug this back into equation 1. So equation 1 is x squared minus y squared is equal to 28. Now here we got y is equal to 48 over x. So if I plug this in for y, I get x squared minus 48 over x squared is equal to 28. Now I can substitute the 2, so I get x squared minus 48 squared over x squared is equal to 28. Now, I'm going to multiply both sides by x squared. So now, for my left-hand side, I have to distribute the x squared. X squared times x squared is x squared squared, or x squared to the power of 2. Now I have this minus 48 squared over x squared times x squared. These two x squared cancel out, so I just get 48 squared. And now this is equal to 28x squared. Now I'm going to subtract 28x squared on both sides. So I get x squared to the power of 2 minus 28x squared minus 48 squared is equal to 0. Now I'm going to set u equal to x squared. So I get u squared minus 28u minus 48 squared is equal to 0. And now I can solve this by completing the square. So I'm going to add 48 squared back. And now I get u squared minus 28u is equal to 48 squared. Now I'm going to add this, so negative 28, or we can say just positive 28. I'm going to add this divided by 2 squared on both sides. And if you guys don't know what completing the square is, you have to go watch a video on it. So I add this on both sides. I add 28 over 2 squared on both sides. And 28 over 2 is 14, so I get u squared minus 28u plus 14 squared, which is equal to 48 squared plus, again, 14 squared. And now the reason I did this, the reason I used completing the square, was because now I can factor this out. This turns into u minus 14 squared, which is equal to 48 squared, I'm going to rewrite as 50 minus 2 squared, and 14 squared I'm going to rewrite as 10 plus 4 squared. Now from here, u minus 14 squared is equal to 2500 minus 200 plus 4 plus 100 plus 80 plus 16. And now if we add these up, we get u minus 14 squared is equal to 2500. And if we take the square root on both sides, we get u minus 14 is equal to positive or negative 50. So we get two equations. Now we get u minus 14 is equal to positive 50, and u minus 14 is equal to negative 50. So u minus 14 is equal to positive 50. I get u is equal to 64. And u minus 14 is equal to negative 50. I get u is equal to negative 36. Now remember how we let u equal x squared. So this means that x squared is equal to 64 and x squared is equal to negative 36. Well, we can't have a number squared equal to a negative number, so this is wrong, meaning that x squared equals 64 is my only proper equation, and if I take the square root on both sides, I get x is equal to positive or negative 8. So these are my two solutions to this problem. And I know that I said this wasn't work, but there actually is a way we can use this to find solutions, not real solutions, but imaginary solutions. So to do that, what I'm going to do is x squared is equal to negative 36. If I take the square root on both sides, I get x is equal to square root of negative 36. And the square root of negative 36 is the same thing as the square root of 36 times the square root of negative 1. Now the square root of negative 1 is the same thing as I, so I get x is equal to the square root of 36i. And the square root of 36 is the same thing as positive or negative 6. So I get x is equal to positive or negative 6i. So these are another two solutions. And these aren't real solutions, but these are imaginary solutions which still count as solutions to this problem. So my four solutions are x equals 8, x equals negative 8, x is equal to 6i, and x is equal to negative 6i.